Some military ideas are simply ahead of their time. The U.S. railgun promised to revolutionize naval warfare, but was quietly shelved after years and billions spent. Across the Pacific, Japan saw opportunity, seeking a game-changer to protect its islands. Japanese engineers took on the challenge, reviving and evolving the railgun. The phoenix has risen from the ashes, now bearing the flag of the rising sun. The American railgun began as a bold vision to leap beyond gunpowder and chemical propellants. Instead of explosions, it would use electricity to accelerate a projectile along parallel rails. The promise: fire a solid slug at Mach 7, obliterating targets with sheer kinetic energy, no explosives needed. Ships could carry hundreds of these safer, smaller projectiles, striking targets over 100 nautical miles away. The project launched in 2005, with defense giants like BAE Systems and General Atomics leading the charge. Early prototypes looked like industrial machines, but they worked, firing projectiles at incredible speeds. The Pentagon poured billions in, seeing the railgun as the future of surface warfare. Test videos of projectiles ripping through steel went viral, symbolizing American technological dominance. Planners envisioned fleets of railgun-equipped ships creating impenetrable defensive screens or delivering devastating firepower. For a time, it seemed the dream of a lightning-fast, all-electric Navy was within reach. The railgun was poised to make traditional naval guns obsolete overnight. But as we'll see, the path from prototype to battlefield proved far more difficult. The American dream of a supergun was about to face harsh reality. Despite early triumphs, the American railgun program hit brutal physics. Hypersonic speeds generated extreme heat and pressure, eroding the rails after just a few dozen shots. Barrel life was too short for combat, and replacing it mid-battle was a logistical nightmare. The weapon also demanded colossal power, enough to power a small city for a moment. Only a handful of ships could handle it. Retrofitting the rest was prohibitively expensive. Costs spiraled, and the Pentagon's focus shifted to hypersonic missiles, which offered similar speed with more flexibility. The railgun began to look like a costly science experiment, not a practical weapon. In 2021, the Navy halted funding, citing technical issues and shifting priorities. The prototypes were mothballed, the research archived. The superweapon was defeated not by an enemy, but by its own extreme physics and budget realities. The project was scrapped, leaving a technological void. As the U.S. ended its railgun program, Japan faced a tense Indo-Pacific security landscape. Advanced missiles from regional powers threatened Japan, and traditional missile defense was too costly for sustained use. Japan needed a high-volume, cost-effective defensive weapon. The scrapped American railgun offered a unique opportunity. Japanese experts believed their strengths in materials science and electronics could solve the problems that doomed the U.S. project. The railgun fit Japan's self-defense doctrine, primarily defensive, ideal for intercepting missiles, aircraft, and drones. In 2016, Japan quietly began its own railgun research, learning from America's successes and failures. They focused on a methodical, step-by-step approach to overcome key technical hurdles. The American dream of a naval supergun was about to get a second chance, under a Japanese flag. At its core, a railgun uses the Lorentz force, a basic physics principle. Two parallel metal rails form a circuit. A projectile completes it. A massive electrical pulse flows through, creating a powerful magnetic field. The Lorentz force accelerates the projectile down the barrel at hypersonic speeds, Mach 5 and beyond. The projectile is just a dense metal slug, no explosives, making it safer and easier to store. Its destructive power comes from sheer speed, capable of punching through armor or bunkers. The challenge: generating enough electricity and building rails that withstand the immense heat and pressure. The projectile must survive crushing G-forces. Turning this simple concept into a reliable weapon is a massive engineering feat. That's where Japan's innovation comes in. Japan didn't just copy the American railgun, they set out to perfect it, their top priority solving barrel erosion. Japanese engineers developed new alloys and composites for the rails, dramatically increasing barrel life. They also redesigned the projectile for better aerodynamic stability and accuracy at hypersonic speeds. A new armature ensures more efficient energy transfer, boosting both velocity and precision. Japan's biggest leap: compact, efficient pulsed power systems. New capacitor technology allows the railgun to fit on existing destroyers, not just specialized ships. This makes the weapon scalable and cost-effective. In 2023, Japan conducted the world's first at-sea firing of a ship-mounted railgun, a milestone the US never reached. Their prototype has shown consistent performance and reliability. By focusing on materials and methodical engineering, Japan turned a high-concept prototype into a formidable weapon. They took the blueprint and built a better machine. Japan's railgun revival is a strategic game-changer for the Indo-Pacific. Its main role: a defensive shield against hypersonic and ballistic missiles, creating a high-volume, low-cost wall of fire. This crucial layer of defense enhances Japan's survivability in any conflict. Offensively, the railgun offers long-range firepower at a fraction of missile costs, changing the economics of naval warfare. Japan's success signals its rise as a defense innovator, inspiring other nations to pursue advanced weapons. It pressures the US and China to accelerate their own next-gen research. Japan will keep refining the railgun, improving barrel life, shrinking power systems, and integrating it fleet-wide. Land-based versions for coastal defense are even being discussed. The weapon born in American labs has found new life in Japan. As it matures, this resurrected supergun is set to become a cornerstone of Japanese defense and a defining technology in high-speed naval warfare.